Hey Chem team. So you guys learned that when a reversible reaction occurs, the reactants are able to convert into products and the products are able to convert back into reactants at the same time. And if the reactants are converting into products at the same rate that the products are going back into reactants, we say that equilibrium has been reached. That is, the rate of the forward reaction and the rate of the backward reaction are equal to each other. And we'll show that here with equally sized arrows. But you've also learned that there are some changes that can occur that will throw a system out of equilibrium. We call these changes disruptions to equilibrium. So to take the same reversible reaction, if we were to add heat to this reaction, that would make it easier to make products. If we added some heat, it would be easier to convert our reactants into products. And so as a result, the forward reaction would be happening at a faster rate than the backward reaction. The backward reaction would still be happening, but just at a slower rate. And so we'd say that this reaction moves right toward the products, that the general movement is to the right. Now what's interesting is that after a disruption to equilibrium occurs, the system will find a way to re-equilibrate, to regain equilibrium. So in our example, when we added heat to this system and we started producing products faster than we were converting back to reactants, what would end up happening is that eventually our reactants would run low. The concentration of our reactants would decrease. And so in the process, the rate at which we were able to convert those reactants into products would slow down as well. Until eventually equilibrium is restored. Now one common mistake students will make is they think that equilibrium means that the amount of reactants is the same as the amount of products. But you can see here that in this case we are at equilibrium even though we have less reactants than we started out with and we have more products than we started out with. What is equal is the rate at which the reactants are converting to products and the rate at which the products are converting back to reactants. And that's it. At this point you guys have a couple of practice problems. We'll see you in class tomorrow.